Good afternoon. I want to welcome you to Strategies for Working Remotely. What can be learned from applying Team of Teams principles to the ECP projects PETSc, Trilinos, xSDK, and E4S. Today I'm joined by a group of great colleagues. We're all part of the ECP or the Exascale computing project. I'm Elaine Rayborn. I lead Strategies for Working Remotely. I'll be moderating today, and I'm joined by our panelists, Todd Munson from Oregon National Lab, Jim Willenbring from Sandia National Lab, Ulrika Yang from Lawrence Livermore National Lab, and co-moderators and bloggers, Reed Malevich from Sandia, Ben Sims from Los Alamos National Lab, Miranda Munt from Sandia National Labs, and David Rogers from Oak Ridge National Lab. So I want to thank everybody for joining us this afternoon. All right, so as I mentioned, we're all part of the Exascale computing project. For those of you that are unfamiliar with our program, this is a very large virtual organization that includes about 1,000 researchers. We are involved in exascale computing, and you can see that we come from all of the national laboratories across the country. And in particular today, what we're going to be talking about is why these national labs and this exascale computing project could be considered a team of teams. And so you'll hear a lot of different ways that we can express what teams of teams are. In the literature, there is a great body of work on multi-systems teams. And what we're interested in particularly is extending definitions of teams to include what it's like to scale, actually, the productivity from small, agile teams to larger groups. And so we're doing this so that we can really accelerate and leverage the agility and the innovation that occurs in small teams. And so there are several ingredients that are really important to Team of Teams, the way that we're looking at it. And we are taking this from retired General Stanley McChrystal's book, Team of Teams, and the citations at the bottom of the slide. So first is important is shared consciousness. And this is really about an aligning narrative or about the ability to understand what the mission is and to know one's role within a larger organization. And that is, again, sharing this consciousness, across many people. Another ingredient is empowered execution. And that is usually that teams will feel empowered to have a certain degree of autonomy and to make good decisions on their own without being micromanaged. And that gets to leading like a gardener. So a team of teams, the leadership style that retired General Stanley McChrystal talks about is actually, instead of being a maybe authoritarian leader and treating your organization like chess pieces that are moved on a chessboard, it's really more about being a gardener, facilitating, guiding, empowering the ecosystem to grow and nurturing it as it does. And then finally, another key ingredient of teams is embedded members or liaisons that actually are able to be part of different teams at the same time, and therefore help with building networks and breaking down silos. And so we believe that all of these ingredients provide opportunities for us to apply these principles to our organizations and our teams. And so what we're going to do today is talk about how several ECP teams are showing some of these key ingredients, what the benefits and the challenges are, and where might we take this and how might you apply this to your own team. So we will have also some, we will, please mute yourself. Thank you. All right, thanks so much. So we will also have some resources for you at the end of our presentation. And with that, I'd like to go ahead and ask Todd Munson to please give our first presentation. Thank you, Todd.
So thank you, Elaine. So my name is Todd Munson. I am one of the developers on the leadership team for the PETSc project. So inside of ECP, I wear many hats, and for this particular presentation, I'll be speaking about our software project from the numerical libraries aspect. So the PETSc Tau project is a fairly large project. It's been around for many, many, many years, starting back in at least the late 1990s. It began up and it started off as a project to provide linear algebra support on some of the big, large systems inside of the Department of Energy. So it's got a focus really on efficient, scalable, customizable linear algebra and nonlinear solvers, numerical integrators, and then outer loop methods in terms of numerical optimization, all geared towards very large scale scientific applications. And we have a pretty broad emphasis on interoperability and with other software products. So we support things in the other packages that we'll talk about today, and you're able to build them alongside of PETSc and then use them within your particular application. So because PETSc has been around for a very long time, and it's an open source software, there's a global community of developers for PETSc, and we get many contributors. So we have contributors both from the United States as well as outside of the States, in France, as well as contributors out of KAUST in Saudi Arabia and other areas around the world. So for a long time, we've been working remotely in some aspects. So some of the groups are more co-located, but overall, the entire project is very distributed around the globe. We do biannual releases of the software. We support all kinds of different data structures and algorithms. And within the ECP, our main focus is on supporting the graphics processing units from AMD and Intel and NVIDIA. And we do that with a sequence of backends that sort of target those architectures. And it was one of the pioneering projects inside of the xSDK, which is the SDK for numerical libraries. So software development kit for numerical libraries that ensures that the libraries can be at least compiled with each other and hopefully interoperable with each other. So to give you a little bit of an idea of the complexity inside of PETSc, this is just a brief overview of our support for the graphics processing units. And it consists of about a couple different areas. So we have the front end on what the people see from the application side, as well as the back end implementation. Our overall strategy inside of our support for GPUs is to provide performance portability. So we want to be able to support all of the architectures for the Exascale machines. And then we want to also provide efficiency and flexibility. So we want to meet the application developers where they're at using their preferred programming model, as well as sort of encourage new developers to be able to use the graphics processing units that we have available. So to do that, we support the tools that the application developers are using while we try to obtain performance in the numerical libraries and kernels on the back end of the solver. We do that by separating the two concerns. So we look at the front end concerns and we provide support for all of the common programming models. We encode those inside of the objects that PETSc uses, typically which are the vector and matrix arrays. And that's what the user provides typically to what the application provides to PETSc. And then the backend implementations are those operations that we do with the matrices and vectors, and those get mapped down into the actual backends for CUDA or Cocos or Sickle or HIP or ROCm. So this is fairly complicated. It requires a bunch of developers who are doing the development on the back end to support those backends, as well as discussions with the application developers on what they actually need. And to support this activity, we're really relying on contributors, and that's sort of where we enter into this whole notion about PETSc being a team or a team of teams, and sort of what goes on into that. The way I like to look at PETSc is in terms of these containments. So we have a little bit of a picture here related to how I actually view the PETSc group. We start from the individual and then we work outwards towards some co-located groups. So we have a group of developers that are co-located at Argonne. And so what we do within the Argonne group is different from what we do across the entire global community of PETSc developers. And then we have a number of communities that are users of PETSc or contributors to PETSc. And so those become the overall PETSc communities. And then we, of course, reside within some external environment. That external environment includes sort of our stakeholders as well as what architectures and things that we need to start. So originally, and to some extent today, a lot of the things inside of PETSc are focused on the individual contributors. So those individual contributors are encouraged or empowered and are responsible for choosing where and what they do within PETSc. So we have an overall framework for integrating stuff inside of PETSc with our merge requests and things like that. But ultimately, we have a set of individuals. Sometimes they form into smaller little teams of 2 to 3 people, or maybe up to 5 people that work on particular aspects or key features of PETSc that they want to develop. The key here is that they are the ones that are choosing the activities that they pursue within the PETSc project. It's not a top-down or directed decision from up above. So I don't tell people directly, you must go and do this particular activity. It really is a bottom-up effect of the developers decide what things they need for either for their application or for other applications. They go and do it, and then it gets integrated inside of PETSc. So we assemble some of our activities into smaller groups or a little bit larger groups. So at Argonne, which is where I work, we have a group of about 10 developers or 10 people inside of the PETSc group that work either part-time or full-time on PETSc. And so because we're all co-located, we can do things that you would normally do that are co-located. We have a little bit more coordination among the Argonne group. So we meet regularly and we are able to discuss our activities inside of Argonne and how it relates to the overall PETSc community. So at this level, we have bi-weekly PETSc Argonne meetings among all of the staff at Argonne to discuss the topics of relevance to the group, as well as to share information on activities and progress and blockers that we're encountering within our activities. Also at Argonne, because we have a fairly large group, we also have a number of people who are supervisors of staff members at Argonne. And so those supervisors, we also meet monthly in what is known as our PETSc consortium group, just to go through any of the upcoming issues we know about in terms of the management side, from finances to grants that are upcoming, and do more of the coordination there. And we were also able to share more information inside of the management group for that. So, and that's sort of where we reside here at Argonne, is within that particular Argonne group. When we go out to the broader community, we have 3 different types of communities, and I think it's useful to focus on those types of communities because they have different needs and wants and desires. So we split our community into 3 different parts. There's the user community. So those are the people who are using PETSc or are developing applications within PETSc. We have the developer community, and those are typically people doing new solvers or adding new capabilities to PETSc that will eventually be used by the users. And then we have a research and development community, and all of this stuff gets mapped down here. And this is really where the communities span the broad geographical locales. So we may have developers in France, or developers in Saudi Arabia, or developers in various regions of the world. And here is where a lot of the challenges come in terms of the coordination of the group and the team of teams concept and how the remote working intersects with this. So as you imagine, because we're very user focused or very focused on the individuals and the individual contributions to PETSc, sort of getting everything moving in the same direction can be a little bit of a challenge. And so we do that at the community level. So here is sort of where we have a developer community. We have regular meetings among the developer community, and these are the PETSc Tau developers forums that we have. We hold those every other week. And this is where we go and we discuss upcoming activities, including plans for larger projects than would normally be completed by a particular individual. And that's also where we go and we make decisions on things like merge requests and what gets merged into PETSc and what doesn't. Things that require additional discussion among the broader team and among the developers community. This has been sort of a new effort to sort of have this coordination over the last couple of years, so 3 to 5 years. So maybe one of the benefits of COVID and everybody having to now work remotely is that we've sort of recognized more of these challenges and provided more opportunities to get input from our developer community and sort of have that interaction that goes on, and to make sure that everybody is at least aware of what's going on and what the major activities are that are upcoming. It's also been a great location for us all to meet and to decide on some of the contentious things that go on. So typically we have merge requests, and some of those merge requests are contentious, with some groups wanting to add this particular feature and other groups not wanting to add it. So it gets them together, forces them to discuss the merge requests and sort of come to some conclusion. And it's a great way to move those forward towards getting eventually integrated into the product, or the development moving away. So the communication channels among the teams actually vary quite a bit. So we have tighter and more communication among the smaller groups, and then we have also some overall coordinating communication among the PETSc Developers Forum. So at the end of the day, we have really adopted some of the team of teams concepts, but they may be in disguise. We certainly empower the individuals to make decisions and decide where they are would like to contribute and what features they would like to add to PETSc. We do some coordination among the groups with our PETSc Developers Forum, and then we also have these sort of smaller groups that sort of are more tightly knit together, where we actually do more discussions and more and have basically a more tighter group and tighter cohesion within the group, trying to keep everybody aware of what's going on, what the challenges are, and where we're moving to in the future. In terms of remote work, we've been doing remote work for a long time. So we use quite a bit Slack and Zoom calls and email lists, as well as the GitHub issues trackers. So we're fairly positioned, and we like using those products, and those products work very well for our team to keep everybody informed. And with that, I will stop sharing and let Reed provide his commentary.
All right.
While Reed is sharing his screen, you have a question actually, Todd, before you leave. It's from Ben. How are the areas of responsibility divided up between developers and others? Let's see, my chat went away.
So it's fairly
between developers or developer teams.
So it's pretty informal. As I said, everything starts from the ground up. So they are all empowered to go and make their decisions on where they want to contribute. So if you want to become a PETSc developer, you can become a PETSc developer. You could do it in a stealth mode, go and download PETSc, and then just start forking the branch and making merge requests. And there's nothing that's going to prevent you from doing that. So at that bottom level, there's really not a whole lot of coordination or dictation or direction that goes along with that. So that I wonder if that answered the question. Then at the higher level, there's been a number of more senior developers. So these are people that have been around for PETSc for a long time, like Barry Smith and Lois McInnes and Jed Brown and Matt Nepley And so those have been developers that have been with the project for the last 20 years. And so they provide a lot of the direction and a lot of the responsibility for and share responsibilities for things like merge requests and major feature requests and things of that sort. So it really is seniority at that level, and not all the time, but mainly they're the ones who are providing a lot of the input based upon their experiences with PETSc over the last 20 years. There's this other question about how does the bottom-up approach in PETSc fit with the mission-driven nature of a big project? So our project is our mission for the project really is to provide high-performance numerical linear algebra, so linear solvers and nonlinear solvers. The deal in that particular realm is there are a lot of options for doing that. So there's a lot of room for people to go and innovate and develop methods and algorithms in that particular space. And so our mission is fairly broad. And so within that mission, we have this sort of notion where we want to cultivate a garden, which is why I called my particular area cultivating a garden. We don't want to adopt a single approach. We need to be able to adopt many approaches. And because we need to be able to adopt many approaches in order to get the best performance, that sort of leads us to having this bottom-up approach where people can go and add new things to PETSc, new preconditioners, new solvers, and then at the end of the day, the user will choose those that work best for their particular application and for the machine they're on to get the highest performance. And there's no one method that is going to always win. As much as I would like it to be, it just does not occur with any of the big high performance machines or the algorithms themselves for big systems.
Thank you, Todd, very much. We appreciate it. All right, Reed, thank you.
All right. Can you hear me? Oh, sorry. All right, perfect. So yeah, hi there. So my name is Reed Malevich. As Elena introduced me, I'm at Sandia National Laboratories. I'm a software engineering researcher, and I'd like to add a little bit of commentary to what's been Todd here discussed with PETSc. So we want to think about what's different about this, right? What's different about this form of organization compared to more traditional forms of organization, particularly in the software world, right? So a common form of open source project community structure is a core periphery structure or an onion. So the idea is that normally what you have is you have a singular core team. You have delineations between who is in the core and who is not, like who is on the periphery, like users and outside contributors. And then there's sort of a top-down hierarchy of governance that flows out from that core to the periphery. So community members who become involved in the project over time may steadily migrate into that core, but the decision-making power still rests in the core, right? And the thing is that in science, in science, engineering, and mathematics, and especially in computing, what we're seeing is that a lot of scientific teams these days really are multi-team systems. They are increasingly multidisciplinary, they are increasingly multi-institutional, and in bringing together all kinds of talent in order to develop scientific software, the governance structure also changes accordingly. So when you saw how PETSc describes themselves, it involves many different teams and communities. It's being built up from the bottom, bottom up from individuals. And each of these different actors are bringing different needs and perspectives to the project. And by increasing their transparency, by increasing that community engagement, they are moving away from having an encapsulated core team and more towards having inter-team, inter-community leadership. Now, if in doing so, what becomes different is that they have to be able to maintain that mutual awareness, and they have to maintain alignment of goals between stakeholders. So that becomes increasingly important in any team of teams contexts. So PETSc has many different groups and consortia and forums and communication that's happening all over the place across different modalities. And the thing is that this doesn't come for free, right? There are countervailing forces here. There are all of these teams, each of which may have their own goals, right? But they have to be able to come together and negotiate and work towards common objectives. And we saw this in terms of one side might say, I really want this feature merged in. The other says, I don't want that feature merged in, right? And they have to find that common ground. But the idea is that they're able to accomplish so much more and be so much more productive than if they were all working in isolation on their own bespoke research scripts. So that's, I would say, is sort of the defining feature that separates this from more traditional forms of software governance.
Great, thank you very much. Appreciate that. So I had asked a question to the audience while Jim Willenbring is bringing up his slides. I had asked a question which was about the different communities. So as we're going through these presentations, keep thinking about your own team and which communities are your teams part of. And as Jason suggested, it's the boundary between the teams or between the communities that can really be difficult. So let's keep that in mind. And with that, Jim, would you like to go ahead and let us know about Trilinos now? Thank you. Hey, Jim, are you muted?
There, I had to find the unmute button. It went away. All right, so I'm going to be talking about Trilinos, as Elaine said. Trilinos exists in a similar place in the ecosystem as Pepsi. It's also a member of the xSDK project. It's part of E4S, two things that we'll talk about later. But we'll start with some background on the Trilinos project. Trilinos is a large software project, consists of about 4 million lines of code. Initially, Trilinos was primarily known for its solvers and preconditioners, but that has expanded to include lots of other enabling technologies such as discretizations and load balancing tools. I'll say a little bit more about that later. Trilinos has always had to deal with remote work issues, as multiple members of the project leadership team and developer teams have been remote workers, some of them for more than 2 decades. Currently, 3 out of the 7 members of the Trilinos leadership team are remote workers. Additionally, many Trilinos developers are located at Sandia in Albuquerque, but there are also developers at Sandia, California, in Livermore, and then scattered in many other places as well. Somewhat similar to Pepsi, where there's a core group. There's a pretty large core group for Trilinos, more like 2 to 3 dozen probably developers in Albuquerque, but there are contributors outside as well. For Trilinos, it's really worth distinguishing at least 2 different categories of remote workers: those who have Sandia network access and those without access. There are some remote workers who work for Sandia and have access to all of those networks and things. I think there was a comment in the chat already about those kinds of challenges. But the challenges for those who have network access at Sandia and who don't are different. So Trilinos is organized around a core concept called a package, where each package provides some set of capabilities. Many of these packages have a package development team behind them, and we'll talk about that later, but it gives sort of a natural organization to all of the capabilities within the Trilinos source code. Trilinos in general is divided currently into 5 different product suites. The linear and non-linear areas are still there, but data services, discretizations, and then also the framework. The framework is just kind of the infrastructure for the project. It doesn't provide specific capabilities that Trilinos is known for, more testing and the integration of those capabilities. So with that as background, the package breakdown means that there are some natural development teams, some smaller groups of people who are working together in a loosely coupled way. Some of the packages don't have active developer teams behind them at this time, and this leads to developers in a more ad hoc manner teaming and solving problems within those packages. So there's some other types of teaming and problem solving that goes on in that way. I mentioned the framework capability a little bit, an infrastructure team. This is another team that contributes in significant ways to Trilinos. Then there's also the Trilinos leadership team, which I mentioned briefly, and teams that are affiliated with user applications. And their DevOps teams, they often interact with Trilinos DevOps teams for how to build Trilinos. They contribute back for building on certain types of platforms and things. There are developers of other applications that are contributing back to the Trilinos source code. Trilinos is an open source code, and so various different users contribute back changes and improvements. Then there's also platform support teams at other institutions. This is often geographically distributed. There are these efforts at Sandia as well. And the E4S xSDK teams, we'll talk about those a little bit later, but they are helping to port Trilinos to new architectures, update how to build in those places, test the code, working with the framework team in testing. And there's also the SPAC team. And so there's a SPAC, if you're not familiar with it, is a package manager for HPC software. Essentially, we'll talk about that a little bit more in the talk later. So there's a wide variety of teams that come together and contribute to Trilinos. So there are some broad common goals, but the goals are not always well enough aligned and prioritized across all of these teams to make things easy. So for example, while one team might care about a particular initiative or doing something, it might not be high enough on their priority list to actually staff that and work towards it. And so that's a challenge, is finding those synergies and working together to solve problems of common interest. Trilinos has many different funding sources. And prioritizing across funding sources can be challenging. The communication required to work together and figure out the right time to tackle a particular issue, that takes coordination and upfront planning. There's a lot of responsibilities that fall on the boundaries between teams. I mentioned one of these earlier, those packages that don't have current maintainers. That's definitely a challenge. But then there's things like certain porting efforts where maybe the framework team is responsible for keeping testing running on a particular machine, but they're not responsible for keeping those tests passing. And so then, diagnosing those problems, figuring out what's going wrong in strange situations, there's always challenges there. And then making sure that the teams that are near to that problem, but maybe not on point to solve them, making sure that they're up to date and so that you can gather information from them. That's always a challenge. Another thing that I want to call out for teaming challenges is tool use and access. I mentioned before, some developers have access to certain tools or networks or platforms, while other developers or users don't. And so there's different tools and technologies being used in different cases, and those can certainly introduce some challenges. Trilinos has made a lot of improvements in these areas, certainly, a long way to go too, but the leadership structure has evolved multiple times and is really trying to work together across these different funding sources and these disparate needs across stakeholders to do upfront planning and achieve greater synergies there, keep teams better informed of what the other teams are doing, trying to flesh out some of these boundaries between the different teams. That's always challenging and can be interesting conversations sometimes, but we've made some progress there for sure. The improved planning I've mentioned a few times, but that really helps to communicate where people are going with things. It helps to promote conversation around issues of common interest. I'll give a good example there. ECP is very interested in the Trilinos SPAC package, the package manager for HPC software. And there are other stakeholders who are also very interested in that. And so communicating amongst all of those various groups to try to find an improved solution that meets all of those needs is challenging, but it can also bring more resources to bear on the problem. So it's useful in that way. And then just communicating more frequently, more intentionally, and documenting things better. I think that's something that can really help remote workers as well, as having documentation and not so much a kind of cultural knowledge amongst the team that's just kind of unspoken. Once that gets written down, once that gets fleshed out and maintained, we've made some progress there, and that can certainly help and is useful for remote workers as well. So that's what I had.
Great, Jim. Thank you very much. Appreciate that. So I wonder if I can get the panelists to share their screens and make some commentary on Trilinos. I have a question for you. Well, first, Ben put a question in the chat, which was how large are the teams?
Yeah, so a lot of the package development teams are 3 to 6, something along those lines. These are not really large teams. There are some outliers there. There are some packages where one person is the team, but then they often team with other individuals in some ways. The leadership team is currently, depending on how you measure it, 7 people. The different platform teams and customer stakeholder teams, they vary more. But around that kind of Scrum team size, the 7 plus or minus 2 captures quite a few of them, but maybe pushing towards the lower end of that, smaller end of that.
And I've got a question for you about the fact that Trilinos has been around for a while. So how might its institutional knowledge, in other words, the kind of like tacit knowledge that is developed over time, how might that impact the team? Do you think that they certainly have ways of working that are different from, let's say, new teams that might form?
The way that Trilinos does things has evolved significantly. So for example, we started out in CVS for version control. We've moved to Git. We started with kind of a single branch with release branches strategy, and now we have a dual branch strategy and things. So I would say that a lot of this has evolved. I don't know that it's significantly different from what other teams do, but I would say that there's some drag and some momentum in some of the older ways sometimes, and it can be challenging to get everybody on board and move forward with certain types of changes.
I do have a follow-up question on that, if you don't mind. I'm very curious to know. So I know that Trilinos really kind of started its life really as a confederation of kind of teams and projects that kind of built, that came together, right? Do you think that has helped Trilinos to continue to grow? Having had to address those coordination and communication issues early on in the life cycle of the project.
I think so. I mean, we've certainly needed to come up with a model that is scalable, and we've had to work with and communicate across multiple teams for a long time. I think maybe I'm so bad with time, but maybe 5-6 years ago, we hit this point where things were big enough that maybe consensus wasn't always possible anymore, and we just kind of had to push through once we had a solid majority. I think early on, the smaller we tried to really form up true consensus, and I think that's been more challenging the larger that you get.
All right, thank you very much. So then why don't we transition now to Eureka, if you don't mind. Your presentation is coming up next. And by the way, as we're taking time to pull up the slides, I just want to thank our bloggers who are speed blogging this panel. So thank you to Miranda and David.
Okay. Hello. I'm still working my computer slow, but I'll be getting there.
No problem.
So I'm Ulrike Young from Florence Livermore National Lab, and I will put this into PowerPoint mode in a second, my slide. And I'll be talking about the xSDK, which xSDK stands for Extreme Scale Scientific Software Development Kit. Still not coming here. Sorry about that. Okay, here we go. All right. Okay, and so it is essentially an ecosystem of mathematical libraries that we're putting together. where the goal really is to make sure that they all work well together. So, and the xSDK also is a project within the ECP. So the project itself is a team of teams and actually consists of a variety of different sub-projects. And so I've listed them here. So there is the original xSDK development, generation, maintaining and improving it. That's one part. There's another one which is working on the research and development mixed precision algorithms, where here really the idea is to put them into xSDK libraries for improved performance. So the overall goal really for all these different sub-projects, as you'll see, is to achieve good performance and the usability of math libraries for application teams on exascale computers. So they're all related in this way. And then there is a third one is to develop batch sparse linear algebra, which basically means that part of it is developing sparse kernels, batch kernels, as well as including batch kernels into sparse algorithms. And then there are two smaller parts, sub-projects, which one is the design of auto-tuning software, which is important. That's actually GPTune, because some of the libraries we have a lot of different parameters, and there it can be useful to have this to figure out what are the suitable parameter for a special application for using the software. And then finally, there is also the design of a code quality kit, which obviously is there to make sure that the libraries do have good code quality. And so all these here they're different parts of the team, each of these sub-projects have different members in a way, although there's a lot of overlap too among them. But I will be talking on for the larger xSDK project, which I call this whole thing, the larger, I will talk about cultural challenges, but I will also want to focus on the other part, which is the xSDK itself, which is actually also a team of teams, and talk about the technical challenges that these bring with it. So, okay, so let's just talk about the actual xSDK product. So the vision for the xSDK, the original kit, was really to provide infrastructure and interoperability of these math libraries to support the ECP applications. That's really important. And one of the key is here the word independently developed. These math libraries are independently developed by different teams with different strategies, etc. So that brings us a lot of different kind of challenges. If any of you ever has tried to build a big application code that involves a lot of different libraries, then they know that can be very difficult. And we do have a lot of application teams within the ECP that use a lot of these different math libraries that are part of the xSDK. So here I just listed 3 of them as an example. WDM app, which is a device modeling team, which uses at least 5 of them. Then SEED is a co-design center that develops high-order finite element software, and they use even a lot more of them. And ExaWind, it is a team that does wind turbine simulations and uses actually 3, they're using more than 3 at this point. They've added more of them. So you see, it's really important that these teams are able, when they build their executors, they do their big simulation, and they're able to build all of these together. And here's just a flow graph where you can see the dependency for the xSDK, where the green dots are actually xSDK libraries. And you can see there are a lot of connections between them, because we do expect interoperability between the libraries to some degree. And you can see underneath the black dots are libraries that they depend on. And you can see also there's a lot of connections in between. So all of this is a complex thing. To kind of stress the term that they're actually individually developed, I just put up here for you to see the different logos for them. You can see they're very diverse, very different styles. And so just like these styles for the logos are different, the software strategies underneath are also very different. And so you have to figure out how can you make sure they work well together. And down here on the bottom, I listed SPAC because as a build manager for the whole xSDK, we're using SPAC, so which has been mentioned before. So what did we actually do? How do we actually cope with the challenge of having to work with these different math libraries and make sure that they all work together? And so one of the things we did, we decided to come up with a variety of different guidelines, which we call the xSDK community policies, which deals with many of these issues, trying to make sure that we're actually able to build them well together, and the application codes can use them in combination. And so the basic idea behind those is we do actually have 16 mandatory policies, which each of the xSDK packages need to satisfy. They address different issues. You can see, obviously, configuring, installing is important. Testing, we do want to make sure that these libraries have good quality, software quality. Other things like they're all high performance libraries, so there's MPI, portability. It's really important for them that they work on a variety of different architectures, in particular for those ECP core libraries, because we do have some libraries which are supported, funded by ECP. They all need to be able to port onto the Exascale machines. I should mention that some of the xSDK libraries are not part of ECP. They're out there, and so we actually welcome all kinds of people, all kinds of packages into this, as long as they satisfy these rules here. Also, they need to be open source licensed, so that's important. We need to make sure there are no namespace conflict, et cetera, et cetera. And we do have also 8 recommended policies which address things like public repository access, error handling, as well as documentation quality. And in order for somebody to become an xSDK member package, they need to be compatible with these community policies, but they also need to have at least one interoperability to another xSDK package. And again, so the two issues here important is that we are able to build these all together, which is why we have these rules, but we also stress interoperability between the libraries. So let me continue about some of these challenges that we have here that this caused. For one of the issues we face is that there are continual changes. For once, even if you just think about the SPAC, the build manager, there are daily changes to SPAC, to the SPAC repository, which we're using. So we have regular annual releases for the xSDK and documentation, and during that time we actually do a lot of testing on many different platforms, including key platforms for Exascale on these different lead architecture facilities here, computer facilities. And one of the things, of course, is the xSDK release schedule is in no way aligned with the individual xSDK library or the spec release schedules. As you can imagine, these libraries also change a lot. We're trying to make progress towards Exascale. So each of these, at least ECP funded libraries, will have more releases underneath during the year. And again, all of these issues can break the whole xSDK. On top of it, you've seen there were a lot of these lower dependency on the previous graph where you saw all these black dots. A lot of the libraries do call potentially the same dependent libraries, but they might not use the same release number, etc. And so that also can cause additional problems. And so we do have a lot of issues because we have these interoperable xSDK libraries. And even so, the xSDK library is also part of E4S, which I know was mentioned before. I know Jim will talk about it more after me. E4S is actually the software stack for the total software stack for the ECP. E4S releases, which actually have a lot more members than xSDK, so there are a lot more packages under E4S than the xSDK. However, they do not have this interoperability. They're more built next to each other, whereas we also have to try to make sure that we manage that. And so what we really would like to have is some effective continuous integration testing that is kind of available all throughout the year, right? And so when we actually do a release, we are already way ahead on our efforts there to get there, because right now there has been a lot of testing. So one of the issues there, in order to make sure that all this is done, is that we also have the problem that not all the library developers are funded. I should say not all of them are funded under the xSDK project, but at least many of them under ECP. But we also have a lot of the library developers that are not funded at all by ECP. Some of them are out the country, et cetera, et cetera. And so what we really would like to have is an automated process that allows us to do CI throughout the year using development versions. And that's very challenging, as you can imagine. And so in order to do this, we actually developed a test plan to deal with that, trying to get an idea of the stability of development versions of the individual libraries. We have a pretty good idea by now. Many of them do a lot of good testing, which is important. But we also know that it is testing the whole xSDK just breaks a lot. And so another idea we had was trying to have more like a multi-level type of testing. As such, we have started to use GitLab runners also for subsets of the xSDK using development versions. So while we still test the original release versions in there, we also have those. The nice thing about these subsets is for once, it's already helped us to find some issues early before they're actually set in stone. But on top of it, we've also noticed that it allows us to test some additional interoperabilities that are not enabled in the overall xSDK spec package, where we had to disable some of them because it's just not possible to get the whole thing working together. And so this allows us to do some additional testing. So again, this is a hard problem. We're making progress, but it's by no way solved. So if any of you has any input, we're happy to take it. But let me now move over to the cultural challenges. And again, this one, I will talk about the larger xSDK project, which has all these sub-projects we talked about earlier. And you can see here, we do actually, this one, here you have the xSDK by the numbers figures. Here you can see we do have lots of team members. Actually, probably it's more than 70, I would think. It involves a lot of different countries, time zones, a lot of codes, etc. And there are a lot of interdependencies too. So, and so we do have a lot of different challenges. For once, I should say the members of the xSDK project coming from all types of different national labs, universities across, as you can see, 6 different countries, some are from industry. So we do have a lot of different people. We do have a lot of distances in time and space. So obviously this is a virtual project. It has to be. Having these different time zones, including having some in Europe, makes it even hard to have regular times. And so we do have actually regular virtual meetings every 2 weeks for several of the sub-projects on a more or less mutually agreed time. I'm saying some of it is historic time and people have just got adjusted to it, but that sort of works. So we do generally meet every 2 weeks for the individual sub-project, at least for the larger sub-projects. So. But when we actually do our releases and in cases when we are ready to get milestones, we actually do a lot more impromptu and informal communication. We use Slack or GitHub pull requests and issues. And I would say for some of the sub-projects, I should also mean things like Overleaf when we write papers together, etc., or Google Docs to write papers together to immediately be able to communicate. Another thing, of course, we do have to deal with is difference in language, communication, etc. Just having all these different people, some of them foreign nationals, if you look from the United States perspective, then of course people in different countries are, of course. And so we do also have to learn to communicate. And there could be differences for all kinds of differences. They different institutions, they have different backgrounds, they understand things differently. So it is really important to learn to communicate with each other. And so one way to do this is, of course, it is harder to do this virtually, especially we are a very big project. And so a lot of times we don't even have the cameras turned on, which is not good. But what do you do if you have 20 people on the call? And so what we also try to do is we try to take advantage of meetings or conferences where we can try to have a big portion of the whole team to meet. We try to have dinners to get more personal interactions. Of course, this was really hard recently during the epidemic where we couldn't have these meetings, but hopefully starting to pick up again. So hopefully that gets better again. And then I think this is really highly valuable to do that. And then, of course, we do have our regular milestones where we have to get things done. And there we have to collaborate. It's really important. There's no way we cannot, considering we are having all these different teams. And also that really helps to bridge communication issues. As you work together towards a common goal, this gives you a certain bond, which helps. Another thing is if you have such a large team, it's also hard to maintain the motivation. And so it's important to have a good inspiring goal. Our goal is Exascale, which is exciting. And so we definitely want to make sure that xSDK is ready for all the different application teams. They're able to use our math libraries in combination. But sometimes you might get overwhelmed because the goal is big, like we're thinking about the test problems we had, that can sometimes feel like, oh, can this even be solved? And so what helps is to break it into smaller tasks, like we have these milestones, a smaller one, and just get motivated when you make progress little by little. Okay, that's very helpful. And then, of course, to acknowledge the contributions of the team members. There are a lot of really great people on the xSDK team, and without them, we couldn't really do it. So, which is really important. Another thing is I do want to mention is diversity. So because we have such a big team, we of course are also highly diverse. So we do have differences in age, gender, race, just nationality, even technical life experience. Like we do have early career people as well as senior staff. They're coming from different labs, different universities, that we have very different cultures. And so again, this gives us also opportunities, right? And so, for example, since we have so many people with different backgrounds, we do have connections to experts that really can be contacted if we need input on difficult problems. I have to say that the oral ECP has been really good for that also. Just give you this access to all these experts and people, right? And making it easier to do so. It's also good we do have different personalities. For example, sometimes when you get stuck, it's really good to have a positive person in there or somebody who can tell a joke, right? That really helps. And then finally, it's actually confirmed by studies that having these different perspectives and thought processes helps to get faster and more efficient solutions. And I'm pointing here to a paper that talks more about this. So that's pretty much what I had to say. I should say that all these points I've made are actually summarized in a paper that we published recently with all these 5 co-authors here. You can see that's available under this DOI. And so thank you. Here just mentioning all the acknowledgements and disclaimer things. And I just want to thank you and end here.
Thank you very much, Eureka. That was really great. I like the way that you focused on the cultural aspects of what it's like to work together and to manage large teams. And I was wondering, as Ben is getting ready for his slides, I'm wondering about just what your leadership, I would say, what are some best practices with respect to leadership or some of the challenges that you've had, and any advice for the audience?
Okay. So I think some of the challenges, especially when we try to have new milestones, I'm trying to put other people in charge of these, because I also want to try to provide leadership opportunities for them. And it's sometimes hard to find them, you know, and I don't know if I've found a good solution if they don't volunteer. Of course, I'm hoping for volunteers. Sometimes I can ask some of them directly if I see that they have really these strengths. If I don't get anybody, I will ask certain people for that. But sometimes I can't find anybody. And in this case, I'll just have to lead that milestone myself, which I'll do. But overall, I have to say, I am really blessed by having a lot of really good people on this project. And so so far we have been able to finish every milestone on time because people are just stepping in when it's needed at the time. So
that's fantastic. Thank you. I will revisit this topic later. So Ben, yeah, thanks. And we're looking forward to your commentary.
Yeah, so I'm Ben Sims. I am a sociologist and I work at Los Alamos National Lab, and I work with Elaine and Reed and other folks on IDEAS and the PETSc team within the Exascale computing project. And for my commentary, I thought I would go back a little bit to this theme of remote work and try to tie it in with what people have been talking about. And this is based on a study that we did at LANL that I led along with Jim Ahrens here, and all these other people were involved. And I'm not going to get into a lot of the details here, but I wanted to just touch on a couple of points. So one of the things we did is we did an in-depth literature review on remote and hybrid work in science. And this was done by my summer student, Will Sutherland, who some of you may know. the thing that I wanted to focus on here is this bottom box about how do you choose the right tools. It's really more about like, how do you choose the right way of interacting as a research team, based on the or a team of teams based on the characteristics, like what you do and who the people are. And we got down to these things like synchronicity, like how much do you need to actually interact with each other in real time? Physical distribution, which a bunch of people on the panel have talked about, like, are you all in one place? Are you in several places? Are you just scattered all over the place? Scale, like how big of a team or project are you actually trying to bring together remotely? How many different communities practice or kind of specializations are there in that community? And then these things like nascence, permanence, and turnover just have to do with how new is the team? How long is the team gonna last? And how often do people turn over in the team? And so those things all come into play. And I think we've heard many of these touched on by the panelists today. And I just wanted to also emphasize this as well, that particularly for this study, we were doing it during a time when people were really exhausted by COVID, and we're focusing heavily on the negative side of remote work. And we wanted to kind of emphasize that a lot of the changes that we saw with COVID actually give us a lot of opportunities to do something new and interesting. And again, I don't want to touch on like every single thing here, but there's just a lot of questions about what are expectations for accountability and availability if you're working remotely. What tools is everyone going to kind of converge on? How are you going to learn to use the tools or adapt your workflow or team to the tools? And just generally, like a lot of issues of how to maintain the team or institutional culture and accommodate different needs and diversity. But on the other side, we have lots of opportunities to rethink the work environment, to improve workflow and security and usability, and maybe expand research areas. I think the idea of team of teams works in part because we can now bring people together in this kind of more global way, and that's just a really interesting a new thing that we're doing, and a new culture that I think we're building here. And so that's basically my commentary. I guess my question for Ulrika and the other panelists would be, are there things that you learn, as we went through this experience of COVID, did we actually learn things that make us better at building teams of teams and bringing people together because of the the challenges that we faced? Or do we come out of that in a better place in some way?
So I personally actually felt like we were already in that place before. So in a way, what ended up happening was when the pandemic hit, xSDK kept going, and we had no problems since we'd already done it before and we had to do it, right? Mm-hmm. But as far as I'm personally concerned, it's actually what I learned because before I always thought I cannot work from home. I have to be at my office to get anything done. And I live an hour away from my office. What I learned was I can get lots of stuff done at home, and actually telecommuting is something like not having to be at the office is something I can do. So that's what I personally learned.
That's interesting. How about any of the other panelists? So any of the other projects? Jim, what about your experience with Trilinos, which had a very large, I think, a group that was actually co-located before the pandemic?
Yeah, so I think in the case of Trilinos, some parts of Trilinos were very accustomed to doing work in a distributed way. Some parts were less accustomed to doing that. And one of the great things that came out of the pandemic, although it was horribly painful in learning this, is that people who hadn't previously worked in a remote work setting have now seen it. And I think they can understand better where remote workers are coming from and some of the challenges that they face. I think a lot of meetings have still remained virtual, And I know that some people have a very strong desire to go back to, you know, in-person meetings, and some people are fine leaving them virtual, but at least that option is there. I think we knew beforehand, before the pandemic, that meetings where some people were there and some people were remote were particularly challenging for the remote people. I think people understand that better now, and those situations can be handled a little bit better than they were in the past, at least. So yeah, I think several things were learned in a painful, drawn out way, because I know that it was very difficult for some people. But one thing that I find is interesting is quite a number of people, you know, really yearned for the human connection during the pandemic. But I think there's other people who are more introverted who were more comfortable in that setting, and you know, actually found it nice to not be smothered by others sometimes. So I think the pandemic, people have spoken with enough different people that there were so many different experiences that people had, and people can relate to one another, I think, better than they could prior to the pandemic.
That's interesting. You know, one thing that I saw, not necessarily with any of the ECP teams, because like Ulrika suggested, these are teams that had very good practices before going into the pandemic. But what I've noticed with teams, smaller teams, let's say in other parts of an organization that were not used to using collaborative tools, or didn't have any policies, or didn't have particularly codified ways of how they would collaborate with documentation, those teams had a lot of, I would say, they had a learning curve, right, to actually establish, you know, those ways of working that were primarily online. And so that's where I think that there was a lot of growth. And then in the larger teams, or teams that were more used to using online communication, those teams were actually able to hit the ground running. And so that's one of the differences that I saw. And so I think now's a good time. I'm going to ask a question while we transition to the next presentation. And this is from Alfred. His question is, are digital nomads an emergent phenomenon in ECP, like in many other software communities? That's a really great question. Anybody have any thoughts on that?
I just wanted to say real quick, this student who did this research had actually studied digital nomads and wrote a very nice paper here that contributed to this. So if anyone wants to look that up. But yeah, it's a good question, because there are, one of the things I noticed definitely coming into ECP is there's a lot of people who are like, well, I work for Sandia, but I live in Minnesota or Florida, or, you know, is that but digital nomads often move around, and so that's another form of digital nomadism. And yeah, I don't know.
Anybody else? Anyone have any personal experience with knowing some colleagues that have been moving around after the pandemic?
Yeah, Steph, this is Ulrika. Sorry, I'm going in and out, but yes, we certainly had several people who are now moved away and are still working with us, right? So, and there's certainly been, I have to say, our lab, Lawrence Livermore, has become very open towards being allowing telecommuting. So which wasn't the case before. That's really changed things. So for the better, maybe. I don't know. We'll find out.
That's great. Yeah, I think we've seen a lot of flexibility, which has certainly brought about a lot of change. So that's good. So now we're going to transition to our final presentation from Jim on E4S. Thanks, Jim.
Yeah, so we've talked a little bit about E4S already. E4S is the largest scale, I guess, of the different products that we're talking about. Pepsi and Trilinos are individual software projects. xSDK has a couple of dozen members. the latest release of E4S includes more than 100 different software products. E4S is an HPC software ecosystem. It includes many of the common software packages that people use in the areas of math libraries, data and visualization, development tools, program models and runtimes and workflows. And so you can see the history of E4S. It's grown pretty quickly, just started in 2018 and has had regular releases right up here until recently. And there'll be another 22.08 release coming here in the next week or so. There we go. All right, so in understanding what E4S is, it's sometimes easier to start with what E4S is not actually. E4S is not a closed system where it's just a collection of DOE software. It's an open architecture, and they invite contributions from outside of DOE as well. And as Ulrike said, there are some xSDK members that are from Europe, and E4S has similar policies. Sometimes people think E4S, if you have it installed on your machine, that it's an entire blob of software, that it is a one large distribution, but really it's very configurable. You can pick whichever pieces of it that you want. And the idea is to maintain this compatibility and interoperability. As Ulrike said, xSDK has a lot of interoperabilities between the software products. Some things in E4S have that kind of interoperability. The greatest interoperability is in the math libraries in the xSDK area. But there are some other interoperabilities, and then there's just being able to be built with consistent sets of options and things like that, and being able to exist in a single ecosystem. E4S is not a commercial product, and it's not just a simple packaging of existing software. It targets the up-and-coming platforms, and it is much more complicated than simply taking 100 different build scripts for different software products and putting them all in the same place and running all 100 of them. And so a few of the things that are most valuable about E4S, in my opinion, include maintaining the compatibility and interoperability between products. And that comes through CI and release testing, as well as the SPAC recipes for building E4S packages on different architectures. I talked a little bit about SPAC before, but you can think about it as a package manager for HPC software. It can build software from source, or when it's available, SPAC has the ability to set up build caches where you can pull existing binaries down, and this can speed up the build process for people considerably if they don't have to compile all of their software from source. So getting into the team composition a little bit, there's a core E4S team, and this is about a handful of people, and those people are geographically similarly located, but there is some remote work going on there. Then there's all of the different product teams, Pepsi and Trilinos, and many other xSDK members, as well as all of the other products that are part of E4S. Some of these product teams are very small, just a few people, and some of them are several dozen people. And so also involved in E4S is the SDK level teams, the software development kit teams. We haven't talked a lot about software development kits so far, but the xSDK is the software development kit in the math libraries area. It was the first one of these, and it was the basis for the model of software development kits. But we now have software development kit efforts in the area of programming models and runtimes, and data and visualization, and workflows, and development tools, and code analysis tools, and there's a number of different teams. These are the actual core teams for these efforts are mostly small, 2 people in some cases, but as many as 6 or 8 in other cases. The other teams behind E4S include the facility deployment teams. These are at each of the major DOE facilities where most of the current work on E4S takes place. These are mostly small, a few representatives, sometimes 2 or even 1. And then also the SPAC team is a major contributor to E4S, keeping things working on different platforms. The CI testing infrastructure, a lot of that comes from SPAC. And so there's all these different teams that are contributing to the health of the E4S ecosystem. So the unifying goal for the teams behind E4S, this goal is to develop and deploy and run scientific applications on HPC platforms. And so there's different pieces of this goal that are sort of farmed out to these different teams. And you'll notice here that all of these groups in some way are involved in porting to new architectures. Most of them are involved in packaging. All of them are involved in testing. And one of the challenges here is to have complementary rather than redundant activities. An example of this is in the testing area. The E4S testing is kind of a smoke test, if you will, just trying to make sure that things are generally sane. Then at the SDK level, for example, the xSDK, Ulrike talked about the testing effort there, and then there's testing efforts at each of the individual product levels. And doing this in a complementary way where each builds on the confidence from the other layers can be challenging, and it takes some coordination, but it really is a valuable thing to have to work together to test these products in effective and efficient ways. Some of the keys that we found on the E4S effort: communication, because with all of the different facilities, with all of the different product teams, there's can be a lot of things going on, a lot of people having problems that the other teams simply aren't aware of. And so this can be challenging to find the right communication mechanisms. Most of these teams have communication mechanisms in place, and they're all different. Maybe not all different, but they're mostly different from one another. What are the workflows for sharing the information? How do you get together often enough and meet and discuss things, but not completely fill your calendar with meetings every hour of every day, but also make sure that people are aware of things and that you're injecting your problems into the other team's workflow so that they're seen and dealt with. And then another key to effective and efficient teaming is making sure that information is available to different people. This can be certainly challenging, especially on new platforms where you might have NDA issues or where you have people, talking across different institutions. And so there certainly are challenges at times in that space. I do want to say about E4S that some projects are certainly more amenable to remote work than others. And I think that because the E4S effort spans so many different teams across different groups and different organizations. As Ulrike said, prior to the pandemic, there was already a lot of, cross-site work and remote workers could fit in pretty well. Certainly within an individual product team, within E4S, some of those teams are a lot less remote and maybe more so now after the pandemic than before, but maybe still very co-located. And it's harder to do that. But I consider this to be a project where remote workers can really thrive and where people have skill sets that can help to bring together different groups and help people to communicate, remove redundancies, and achieve efficiencies. There's a lot of opportunity in this project. So that's what I had, Elaine.
Thank you very much, Jim. I especially like how you ended your presentation on actually opportunities for teaming, and that leads directly into a question that Jason had. Jason, I wonder if you wouldn't mind unmuting yourself, and if the panelists would show their video cameras, let's all have a discussion now, and we welcome and open the floor up to any questions that anyone might have. So yeah, go ahead, Jason, thanks.
Yeah, thanks, Elaine. Jim, this is perfect timing because as I was typing away with the question I've been dying to ask you, started immediately talking about communication. So question is, in the team of teams context, like, how do we prevent siloing? Like, are there practices to be suggested? Are there particular tools to use? Like, there seems to be such a tendency for like the littler teams to go off and do their good things off in a corner, without understanding of how that fits into kind of the overall objectives, and helping the team of teams to execute on mission, whatever that is. Does that make sense?
Yeah, I don't have a perfect answer for this. If I did, that would really be helpful. But there's a couple of things that I've observed that help maybe. So one is, if you can make different teams that are, near to other teams' efforts, aware of their issue trackers and workflows and things, and you can inject things as they come directly into their workflow, that they will see it and they will process it. That really helps, because if you kind of just send somebody an email or you mention it at a meeting, and that may or may not gain traction. The other thing is picking the right cadence of meetings and the right collection of meetings. And this is really hard to do because people can really get washed over with meetings. I mentioned a little bit, but I'll give an example. On E4S, Mike Haru observed 2 or 3 months ago that he had on his calendar, I think it was 6 or 7 different meetings over a 2-week period, different categories of meetings, some of them weekly, some of them bi-weekly, that dealt with E4S. And he decided that, the best thing to do to manage this was to create one more meeting. And it sounds a little bit like, oh goodness, get this meeting, but what it did was it brought the right stakeholders together in the right places. And you have to look at the specifics of the network of interactions. And so where I see a lot of disconnects, for example, and potential for siloing, is where you have like different product teams trying to port their software to a particular platform or something. Well, then you also have the facilities teams working on those same platforms using E4S, trying to port that software. And often the facilities teams might talk together. That's something that you have to grow over time, those relationships, but they're often not talking to these teams. And so I found myself in meetings with both of these kinds of groups of people. And so then you start to try to be a go-between in breaking down this silo, and then trying to figure out, what is the right way to do this, and what are the right attendees at these meetings, or what are the right communication patterns, issue tracking workflows that are more efficient, right? Because if you take all the people from all of these meetings and you plop them into all of the meetings, then you have a mess. So I know what I said probably doesn't sound efficient, and it sounds a little bit crazy, but it can be efficient if you look at the specific network connections and try to make sure that you're connecting those.
Yeah,
it's incredible. As you're say you're approaching a new platform, you'll talk to one group and they'll be running into the same problems as this other group, and you just have to bring these people together but do it in a way where you're not spending 90% of your meeting time where 90% of the people are tuned out. I think in general, cutting back on meetings is better than adding more meetings. But being intentional with those meetings is important to breaking down silos. And it's especially important in cases where the teams haven't worked together before and aren't familiar with each other and their workflows to some extent. If you can build up familiarity and establish common vocabulary and common goals, then sometimes you can do without those meetings later. Anyway, I don't know if that helps at all.
Just to add to Jim's point here, towards the end on the common vocabulary and everything, just report from the literature on kind of having teams of teams, that identity is really critical here. Is another thing I'd add. Because on one hand, teams need to have a strong sense of identity amongst themselves. So they work together effectively, all these different teams, and they're empowered to do their own thing and accomplish, whatever the objectives in the best way they know how, right? On the other hand, they also have to feel a sense of identity with the team of teams, right? And say, I know who else is out there. I know to whom I'm responsible. I know how I can help. I know what they need. They know what I need, right? And having that mutual awareness is really important. When you have a breakdown in that, that's kind of oftentimes is like they have to have a reason to want to break down those silos, right? They want to feel motivated that I see a reason why we need to be meeting, and then we need to be talking, and we have advantages to doing so. And there's that. If they have that sense of shared identity and that sense of shared task and purpose, it makes it a lot easier to break down those silos.
I've got a question that I've been dying to ask, actually, which is what comes first, the team or the code? So does the code development make the team of teams, or do the people make the team of teams? Anyone have any thoughts? Can be anybody right now.
Chicken or egg?
That's an interesting question, because in some cases I would say you have the code first, and as the code grows, then maybe you have the teams, right? So it really depends on the situation. But in the other case, so I don't know what you define as the code, I guess. Like if you say the xSDK is the code, which really is not the code, but that's the product, right? Then you would say the team of teams was there first. In that situation, the people were there first. I mean, you had these different parts you try to put together, but so it depends. I think the situation where you can see both of them happening.
So it's funny because I agree with Ulrike, but I would have said it the other way, actually. I would have said that in the case of the xSDK, the code existed first, but the code was the individual product codes brought together under the umbrella of xSDK. Now, if you're talking about the code associated with the xSDK, then it's the people. I think at the individual product level, it's the people, and they write a code. They write a code base. But these umbrella level things like the xSDK and E4S, they're bringing together many existing codes, many existing teams, and forming larger teams. So anyway, that's the way that I see it break down.
Yeah, and I think I was thinking in terms of the actual original proposal that brought this together, which were the PIs on the codes.
Yeah, thanks for answering that question. I asked it because I actually felt that with respect to Jason's question about siloing, one of the things that we've noticed in our IDEAS project is that when a code base grows and you begin to have new users, then that's the point where you're starting to introduce new people, and the communication has to change, and maybe the structure needs to change. And so that might be an indication of that in some cases, the growth of the code or more people adopting the code base can also contribute to the of teams part. And Ben Fulton has asked a question in the chat, which, Ben, I don't know if you'd like to unmute yourself and ask this question.
Sent me rushing for my headphones. Yeah, so Conway's law is the thing that it's a law that says that organizations design systems that mirror their own communication structures. And I was wondering if you're finding that to be the case in sort of your I think it refers more generally to industry type situations, but it'd be interesting to see if it's also happens in these scientific environments. And also post-pandemic, how do remote workers affect Conway's law?
Great question. Thank you. Go ahead, Reed. You have some thoughts.
Yes, I do have some thoughts on this, because in general, yes, I've seen this quite often. Conway's law, for example, I know we did some work with a team. They have a multi-physics problem, right, that requires 5 different sorts of physics. And thus they have 5 teams contributing 5 codes, each of which has to interoperate with each other in order to collectively solve this multi-physics problem. So in that sense, yes, the division of labor and like the breakdown by institutions and other organizational structures do affect software in general. Though I think that an interesting question that you're raising here is, does the transition to remote work, does remote work affect organizational and communication structure in a way that would inform like the software structure? And that's actually a question that I've not really considered before, but I turn it over to other panelists. I think Ben may have some things to weigh in on communication structure and remote work.
Yeah, this is another, I was just trying to think about it. It is an interesting question. And again, I would want to refer back to this student, Will Sutherland, who wrote up a whole thing on Conway's law for us. Yeah, I mean, I think Conway's law kind of has two directions. If you really think about it, is sometimes that organizations design technologies that mirror their structure, and sometimes they adapt their structure to the technologies that they work on. And so there are some, I mean, there's just a lot of questions here about, we have new technologies, people have new abilities to work as digital nomads, or, work in an organization and live someplace else. And it does raise kind of questions about, does that impact the way, does it create new possibilities or constraints on your ability to manage these projects? I think would be a question.
Yeah, I think that we've seen in organizations that were primarily co-located and really valued face-to-face communication, we've really been able to expose actually I would say the vulnerabilities of relying on one particular communication modality in any organization. And so what I think has been one of the greatest challenges and one of the greatest opportunities about remote work is that, in a sense, it really is holding up that mirror and asking the organization, are you still like this? Do you need to change now because there are external constraints that are changing your workforce right under your nose? Do you need to become more aware of it? Do you need to actually change your organization communication to adjust to it? So, I mean, this has been a really exciting panel, and I want to thank everybody for coming. And I especially want to thank our panelists and moderators and our speed bloggers. So we can look forward to a blog article on this panel in the BSSW website. So again, thank you so much, everyone. I hope you're all having a great summer. And if you have any other questions and like to follow up, you know where to reach us. Take care, everyone. Thanks for your attention today.
Thank
Bye.
you. Bye.